Precalc chapter 9 section 3. So this is the last section for conics. The last conic to talk about is a hyperbola. And so we're going to do the same thing we've done in the past few shapes, just with the hyperbola. So a hyperbola, the locus for a hyperbola is the set of all points xy in a plane which has a constant difference between the two distinct points called the foci. So for the ellipse it was the summation, for here it's the difference. So we still have some center. So here's our center. And then a hyperbola has kind of like a parabola on both sides, which are actually, these are called branches. So we have these two branches. And if you take any point on either one of these, then the distance to the foci, the difference between these, would be the same or constant. So we have these two foci. So take any point on either of the branches. Let me take, this is D1, and then take the distance here, D2. If we subtract that, D2 minus D1, that value will always be the same for all of the points on either branch. And that's the locus. So if we want to actually look at the different parts of the hyperbola, so we understand what it's made up of, we have the center, which we already stated. Then we have the foci. So here's a focus, and here's another one. And so the distance from the center to each of the foci is still going to be C. We have our vertices, which are still on each of the branches. So there's a vertex. There's another vertex. Now, if we go in the opposite direction, we don't have co-vertices here. They're not part of the shape. But we can still go the other direction, B units, B units, and then B units here. They help us create a rectangle. So if we went A units the other direction, here's our A value and A value here. And we turn this into a rectangle. And so you can see how I can make a vertical line here. We have a vertical line from this vertex, and then we have horizontal lines B distance from the center, and that creates this rectangle. If I draw the diagonals through here, the diagonals are actual asymptotes for the branches. And so we still need our A and B value, but they help us create these asymptotes, which help us then draw the shape. And so we have our A value still to the vertex, our C is still to the focus, B is the opposite direction, which helps us build this rectangle, which then creates our asymptotes. But the shape itself is the black branches, the hyperbola. And again, we're talking about vertical and horizontal. And so if you look at the actual equations, we have, these are all for the hyperbolas. We have the vertical and we have horizontal. Here is the big equation for each one of them, with the shifting of the center. Notice how for these, the A squared and the B squared always stay the same. And so you think about the A squared is always the denominator of the positive term, because we're subtracting two fractions here. It's this fraction minus the other fraction. So the positive fraction always will be it would be the denominator. And so that's kind of how I remember what goes for the hyperbola. The numerator, then that switches. So here, vertical, then the y is above the a squared, y is on the positive fraction. And then for horizontal, the x term is the numerator for the positive fraction, positive term. So that's how I tell the difference between horizontal and vertical for a hyperbola. We still have the formula for focus here, but instead of being a squared minus b squared like it was for ellipse, now it's a squared plus b squared. So it changed. We have our asymptotes, and here are the formulas for the asymptotes, different ones, and the difference here is the A over B and then B over A. They become reciprocals of each other depending on whether it's vertical or horizontal. And if you look at the shape here, one of the big differences between the ellipse and the hyperbola, what changes is here C is actually bigger than A. When the focus becomes inside, smaller than A, then the branches open inward and create that ellipse. When C is outside, bigger than A, it creates the hyperbola. So let's sketch this one. So first thing notice here is that the HK, the center, is going to be 0, 0 because there's no plus or minus for either the X or the Y. And then I also know that it's going to be vertical. It's vertical because the Y is the positive fraction. So Y is part of the positive fraction. So Y is positive. And then we know that the A squared is a positive fraction, so that's going to be 25. And B squared is the other one, 81. Now notice here how our A is actually smaller than our B, and that's okay as well. So our A is going to be 5, our B is 9. And so if I want to sketch this then, I'm going to plot my center, and then I'm going to move A in the vertical direction because it's a vertical hyperbola. So I'm going to go vertical up 5 and down 5, and that creates our vertices. And then let's use our B value in the other direction and go right 9 and left 9, and that's our B value. And so that creates our rectangle with those points. We want the rectangle so we can see our asymptotes. And so my asymptotes are going to be through the diagonals of that rectangle. And then that will help me draw my branches. Now we have to be careful. Our branches are vertical, so they come off of A. So they start here and go towards our asymptotes. And so that would be the sketch in red of that hyperbola. So let's write one in standard form, given this setup. So I can see the subtraction here kind of tells me that's going to be a hyperbola. And then we want to get a 1 on the right hand side, so we're basically just going to divide by 36 to both sides. If we do that, we get x squared over 9 minus y squared over 4 equals 1. And so we still have a center that is 0, 0. We have our vertices that are using our A value, which are going to be 3. So it's going to be a horizontal. And so A value 3 means I'm going to move left and right from the X value, because it's horizontal. So it's going to be plus and minus 3 come 0, our actual vertices. Our foci use C, so we need to find C, and C squared equals A squared plus B squared. So we need our B value. B in this is 2. So then C squared equals 9 plus 4. So C squared is 13. So C is root 13. And so the foci are going to be plus or minus root 13 comma 0. And our C value is that root 13. And then the asymptotes, and we can use our formula sheet to help us out with this, but because it's y equals k plus or minus b over a times x minus h, and our k and our h are 0 here, but it's plus or minus. B is 2, a is 3, so 2/3, and then x, because our h is 0. So those would be our asymptotes, which all of that will help us sketch it. And so if we 0, 0 is our center, we have 3 to the right, 3 to the left, 2 up, 2 down, those are our B values. That creates this rectangle. But you can see the slope is going to be that 2/3, which is part of the asymptotes, the equation we got, which creates these diagonals. The whole point of these diagonals is just help us sketch it so we know what are we approaching. And so it's horizontal. One of the common errors from students is to not know which of these points to go off of for our branches. So it's always off of A. A here is left and right, so I have to start from this point and then go to the right. And use the asymptotes to see what approaches. So those are the blue branches. Let's find standard form given this information. So we know our vertices, and I'll sketch it. Vertices are 1, 2, and 3, 2. So these are our vertices, which means that the branches are moving like this. So I know that's going to be horizontal. And that's important because now I know for the formula it's y equals k plus or minus b over a times x minus h. And so if I look at our asymptotes here, they have a slope of 1. So b over a has to equal 1. If we look at our picture here, we have the center has to be right between the two vertices. So it has to be 2, 2. And so the distance here is 1, which is a. So a has to equal 1, and therefore b has to equal 1, so we divide and equals 1. Now realize, just because you get this fraction equal to 1 doesn't mean it has to be 1 over 1. It could be 2 over 2, or 3 over 3, or 4 over 4. So we need to use our drawing to find one of the two values, b over a, to find the second. So now that we have these two, we can write a lot of our form here. A always goes first, so 1 squared. And then b is the same, 1. And then because our center is 2, 2, then we put the x, it's horizontal, so x comes first, x minus 2 squared, and then y minus 2 squared. So they look quite similar, but because of the subtraction here, it's a hyperbola, and if it was plus, it would actually be a circle. And that leads into this, is how to classify a conic. So this is the full form for a conic. We have all the different parts or terms you could have. And so what are you looking for to see if it's a certain shape? So it's a circle if A is equal to C. If the coefficients for your two second degree terms are the same, then it's a circle, and that includes a sign, so it has to be both the same sign and the same value. So the parabola is if a times c equals 0. Basically you can say if you only have one squared variable, so either have x squared or y squared. It's an ellipse if a does not equal c and it's the same sign. So if the coefficients for your second degree terms are not the same, then it's going to be ellipse. And a hyperbola is if it's just basically a different sign. And the not equal to just means different sign. It could be the same actual absolute value, the last example we did, but it has to be a different sign. And so looking at these, we should be able to classify what kind of conic they are. So here, look at my square term, 1x squared minus 3y squared. The minus here, different signs, tells me it's going to be a hyperbola. Here, x squared, y squared, 1, 1, everything's the same exact, same coefficient, tells me it's a circle. So I don't care about any of the rest of the terms, it's going to be a circle. Here, x squared minus 4y squared, so that there is a hyperbola. And then here, 2x squared, 3y squared, that is an ellipse. Ellipse because they're different. The different numbers, same sign. So none of these have examples of a parabola, which is pretty easy to see that you only have either x squared or you have y squared. You don't have both of those terms. So I'm going to call it good for the night, and we'll see you tomorrow.